We are on chapter 8. This is a chapter where we're going to talk about rhythms that originate from your atria. So if you remember all the way back in chapter 1, we learned about the parts of the heart, and we know that our atrium are the top two chambers of the heart and our ventricles are the bottom two chambers of the heart. So in this chapter, we're going to focus on rhythms that are going to originate in your atria. Now, chapter 7, we talked about rhythms that were originating in your sinus node, which is your original pacemaker of the heart. That is coming from a single foci. But when we talk about the atrium, the difference with these rhythms, the impulses that are going to originate from here, is that it can be coming from different foci within the atrium. So if you remember your sinus node, the impulse begins there, and then it's going to separate into tracts, your internodal and your interatrial tracts, to get to your AV node. It's sending that impulse to all parts of the atrium to touch that muscle, to cause it to contract, to get that mechanical reaction. All of what we've been talking about thus far. So chapter 8, we're going to talk about rhythms and impulses that are going to come from within your atria. So, atrial rhythms, they originate in one or more irritable foci in the atria. Again, this is that impulse. If you don't know what I'm talking about when we're talking about an impulse or the foci or the conduction system, you need to go back to chapters 1 and 2 and review. Your foci is where that impulse is. And when that foci touches the heart muscle, it causes depolarization, which is your mechanical response. Depolarization is the switching of positive and negative ions, your sodium and potassium, and also the releasing of calcium to get a depolarization, a contraction, to get that impulse, that spark. It's going to head down the conduction system pathway, which is, what is that conduction system pathway? Again, we're going back to chapters 1 and 2. That is when the impulse starts in the sinus, goes through your atrial tracts to your AV and down to your ventricles. That's the pathway. The atrial rhythms are also called ectopic rhythms. That is something that you might want to write down, is what are atrial rhythms known as, because this could be a question on your national certification. So what's the word on atrial rhythms? Well, the atrium is another pacemaker of the heart. So let's say my original pacemaker of the heart, the sinus node, is not working. Then who's next in line on that pathway to ignite a spark, to send an impulse, to depolarize? That is your atrium. They're usually rapid rhythms that usurp the sinus rhythms. Occasionally, you will have an atrial rhythm that is slow. Treatment is aimed at returning the heart to your atrial rhythm to a sinus rhythm. So chapter 7, we talked about your sinus rhythms. And the very first rhythm that you learn is a sinus rhythm. And we're going to compare the rest of the rhythms that we learn to the rules of that sinus rhythm. Our ultimate goal is to get the heart back to the sinus rhythm, because the sinus node is the original pacemaker of the heart. That's my 60 to 100 beats per minute, and that's what we want the heart to be at. So atrial rhythms are extremely variable in their presentation. Some atrial rhythms are regular and others are completely irregular or even chaotic. So you should know by now what I mean when we talk about regularity. That's one of your questions to interpret the rhythm. Is that rhythm regular or not? And if you remember, to determine the regularity, you count the little boxes in between the consecutive QRSs. And if the consecutive QRSs are only 1 or 2 boxes different from the QRS before, then that rhythm is regular. But if they are multiple boxes different, then it is irregular, and then it could also be interrupted by a pause or a block. Most of our atrial rhythms are rapid and very few are slow. Your atrial rhythms have multiple and variable possible criteria. So this is coming back to our questions from chapter 6, and how do we interpret that rhythm? And here we find that our atrial rhythms, they're going to have variable criteria. So for example, your P waves can be upright and your atrial rates, the heart rate of the P waves, can be greater than 160 at rest. Or there could be no P waves at all. Wavy or sawtooth baselines between your QRSs they present instead. Or your P waves can be less than 3 different shapes, less or greater than 3 different shapes. The premature abnormal P wave, with or without a QRS, interrupted another rhythm or heart rate. P waves cannot be discernible. So you see that your atrial rhythms, that we have a lot of different variables. So just knowing about these variables is great, but really what you really need to focus on is when we learn about the different types of rhythms that we can have, the names of those rhythms and what rules go with those rhythms. That's the best way for you to learn the criteria. So again, we're going all the way back to chapter 2 now. We're looking at your conduction system here, and this is from a single focus. So I am going to use the color, let's do purple. And you notice right here is my sinus node, and right here is my atrioventricular node, my AV node, and here is my bundle of His, which houses my ventricles. So we see that there is nothing coming from my sinus node, but we see this little sun-like image over here pointing towards my AV node. This is going to be one foci right here. The impulse is coming from one place. So if I were to look at the rhythm from this foci, all my P waves should be matching because they're coming from the same foci. Now look at this image here. Notice there is nothing coming from my sinus node, but I have 3 sun-like images, 3 foci, all pointing towards my AV node, which means I've got 3 different sparks coming to my AV node, and each one of them is going to have its own unique P wave, which means I can have more than 3 different shaped P waves. So if you remember from your questions, the questions that you use to interpret your rhythms, it asks you, do you have P waves? Are they upright? Are they matching? Are they married? In this case, they would not be matching. And why are they not matching? Because they're coming from 3 different foci, which means they're going to have 3 different P waves. And if you remember, when we got further into chapter 2, we talked that your P wave represents your atrium and your QRS represents your ventricles. So you remember you have your atrium right here. I'm going to just put A. And then you have your ventricles right here. So if I have P waves, then I know that my rhythm is either going to be coming from my atria or from my sinus node. If my sinus node, all the P waves are matching, then I can assume that it's coming from the sinus node, but it could also be coming from the atria. So now we're going to get into the specifics. So when you look at this chapter, you're going to notice you have a lot of rhythms that you have to learn. If you look at the back of your chapter, before you get to your practice problems, there should be 2 pages that show you a list of the types of rhythms that come from the atria and all its criteria. And then below that on the next page should be all what the rhythms look like for those rhythms. So the only thing I can suggest you do is to get a note card. Put the name of this rhythm. So for example, you would put the WAP, W-A-P, on one side, and then on the back of that card, write out wandering atrial pacemaker and what's the criteria. If you have trouble memorizing the criteria for each one of these rhythms, you just think of your 5 questions and then that's the criteria. And then of course we need to know what effects it has on the heart, what kind of treatment we're going to give that patient, and why is that patient having this type of rhythm. Also, when you're looking at these rhythms, so there should be 8 images in the the summary of the before you get to your practice problems in the back of the book. I want you to couple them. So if you notice your WAP and your MAT, your wandering atrial pacemaker and your multifocal atrial tachycardia, you notice they're coupled here on this slide. And you're going to realize the similarities between these rhythms and your sinus rhythms. So it kind of gives you a better sense of how to keep everything in order when you are looking at these. You can easily compare them to the other as long as you know what the difference is. So, wandering atrial pacemaker, also known as the WAP, the WAP, and multi-atrial tachycardia is also known as your MAT. These rhythms occur when the pacemaking impulses originate from at least 3 different foci in the atria. Your WAP is an example of a slow atrial arrhythmia, and your MAT is going to be rapid. So how is this similar to your sinus rhythms? Well, your sinus rhythms, if you remember, you have what's called your sinus bradycardia, which is your slower rate, and your sinus tachycardia, which is your faster rate. So if I'm talking about the atria, I am going to have a WAP, which is my slower rate, and a MAT, which is my faster rate. And these can come from at least 3 different foci in my atria. A little cheat sheet is your MAT. That T stands for tachycardia, faster rate. And that wandering atrial pacemaker, if you think about it, I like to use a scenario to compare to is if I'm going shopping. If I go shopping and all I need is milk, am I going to shop around that store, see if there's something on sale, take my time, see if there's anything else that I need, or am I going to go straight to that milk? If I'm going to go straight to that milk and get out of the store, I got out of there pretty fast. I'm in the tachycardia mood. But if I'm going to walk around, I'm wandering. I'm looking for that clearance aisle. I'm looking for something else, or I have time to waste. I'm wandering around the store. I'm going to be at a slower rate. So that's just a way for you to try and connect which one is the slow rate and which one is the fast rate. And always keep in mind we are talking about the atria, and that A stands for atrial, so that should also be another hint. Your WAP and your MAT, they are exactly the same rhythm, just with a different heart rate, which we already know that the WAP is slow and the MAT is fast. But now the question is, what is considered slow and what is considered fast? So, for the WAP, the mean rate is going to be less than 100, whereas your MAT rate is going to be more than 100. So if you remember your sinus node, the rhythms coming from that node are going to be between 60 to 100 beats per minute. This is your normal heartbeats per minute. But if I am a WAP or a MAT, I am considered a slow atrial rhythm if I am less than 100. But I am considered a fast atrial rhythm if I am more than 100. If you look at that slow rhythm, we're usually going to get a mean rate, which is in the 50s or the 60s. What does this mean? We're going all the way back to now chapter 5 and chapter 6. How do you know the mean? You get that is the heart rate, beats per minute, one of your 3 methods. It is your 6-second method. When you multiply your QRSs by 10, and that's going to give you the mean, which means your average rate. But to get a more precise rate, we're going to use the memory method or the little box method. Notice, what is our regularity on the WAP and the MAT? They are irregular rhythms. Your first sign should be that P wave not matching, right? P waves are going to have 3 different shapes because they're coming from 3 different foci. Some beats, you may not even be able to see the P wave at all. Your PR interval is going to vary. So remember, our normal sinus rhythm, our PR interval needs to be between 0.12 seconds and 0.20 seconds. But if I am a WAP or a MAT, I am coming from the atrial, and my PR interval is going to vary. My QRS will remain less than 0.12 seconds. So what can cause us to have a WAP or a MAT? So the WAP, the wandering atrial pacemaker, can be caused by medications, hypoxia, vagostimulation, or MI. Remember, your MI stands for myocardial infarction, also known as a heart attack. Your your MAT can be caused by COPD or heart disease. What are some effects that it has on the heart? If I'm a WAP, which means I am a slower rate from my atrium, I'm not usually going to have an effect on the heart. But if I'm a MAT, anytime we have an increased heart rate, we can affect the heart. And what effect is that going to have? It is a decreased cardiac output. Remember, last chapter we talked about some of the effects of the heart, and the most common effect on the heart is decreased cardiac output. What does that mean? That means not enough blood is coming into the heart and going out of the heart to feed the body. So it's at a decreased output, which means your heart rate is working harder. How do we treat this? We're going to treat with a WAP, usually non-needed. But for the MAT, we're going to give beta blockers or calcium channel blockers if signs of decreased cardiac output exist, meaning we've got to slow that heart down so it can pump more accurately. So this is what our wandering atrial pacemaker looks like. So remember, this is our slower rate. So the first question that we would ask ourselves is, do we have QRSs? Yes, we have QRSs. Remember, QRSs represent your ventricles. So if I have a QRS, does that mean my ventricles are depolarizing? Yes. Now, the next question is, do we have what is your rate? I'm sorry, your regularity. So then you're going to count the boxes in between. And remember, 5 little boxes equal 1 big box. So I'm going to count by 5. 5, 10, 15, 20. And then I'm going to count those little boxes that are extra. 23 here and 23 here. I'm sorry, and 3 there. So that's 26. Next one, 5, 10, 15, 20, 25, maybe 23 and a half, 4, 5, I'm going to say 26. 5, 10, 15, 20, 25, 26, 27, I got 28 here. Let me double check that. 5, 10, 15, 20, 25, 26, 27, 28. And then 5, 10, 15, 20, 25, 26, 27, 28. Would you say that 26 is 2 boxes away from 28? If you do, you're correct, which means in this case, my rhythm is actually regular, but the rules tell me for a WAP, they can be irregular. So again, sometimes our book does not give us the accurate example that we need. Our book makes mistakes. We all make mistakes. Nobody's perfect. I'm not going to let this concern me. Then my next question is, so we know that we have QRSs. We know that it's regular. Then we need to figure out that heart rate. So for a regular rhythm, to get the heart rate, we're going to multiply my QRSs by 10, 10, 20, 30, 40, and 50. And remember from your rules, the mean rate for a WAP should be between 50 and 60 beats per minute. Then my next question is, do I have P waves? Yes, but are they matching? No. And remember, the wave before your QRS is P, and the wave after it is T. Before it is P, after it is T, and then P. So if I were to look at all my P waves, you have 1, 2, 3, 4, 5 of them. Out of these 5 P waves, are they matching? No. The first and the third one match, and the second and last one match, and then this one does not. So I see 3 different P waves, which mean I'm coming from 3 different foci. My heart rate, my mean is 50, and I am a regular rhythm. I am a wandering atrial pacemaker. Then the next questions is your QRS and your PR intervals, which we'll leave that for practice. All right, now look at your tachycardia. This is obviously a tachycardia, right? You can almost predict now who has a slow rhythm and who has a fast rhythm. You should be able to decipher that by now. So let's look at, my first question is, do we have QRSs? Yes, look at them all. Yes, 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 yes. Plenty of QRSs. All right, next question is, what is my regularity? I'm going to count the little boxes in between 2 consecutive QRSs. So my first set, I have 5 for that whole box, plus 1 is 6, 7, 8. I have 8 little boxes here. My second one, I have 4, plus 5 is 9, 10, 11, 12, I'm going to say 13 here. My third one, 10, 11, 12, 13. My fourth set, 5, 6, I'm going to say 8. My fifth set, 10, 13. And I'm counting these little bitty boxes in between my 2 consecutive QRSs. So here goes 5, 10, 11, 12, 13 here. 5, 6, 7 here. 9, 10, 11, 12 here. 10. So you can notice the further that you go, the more irregular it becomes. 13 boxes here. So between 8 and 13, is that 1 to 2 boxes difference? No, it's way more, which means that I am irregular. So I have QRSs, my first question. My second question, what's my regularity? I am irregular. My third question is, what is my heart rate? So for an irregular rhythm, we're going to have to do the memory method or the little block method to get the range, right? Which I'm not going to do that right now. We'll do it on the practice. But to get an idea, the quickest method that I can use is going to be either the memory method or the 6-second method. So I'm just going to stick with the 6-second method to make it quick. So we'll have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, and 20. My heart rate is 120 beats per minute. And remember, since it's an irregular rhythm, you would have to do the memory method or the little block method, and you would have to get the range. Okay, next question. Do we have P waves? Yes, remember, your P wave comes before the QRS and then your T wave. Now notice, can we tell, is this a P or a T? No. Would you say that we're missing a P here? Yes. So we're going to, let's not look at this first section because we can't really make it out. So let's look at the next one. Here's a P. Here is your T. P. Look what happened to your T. And look at your P. So sometimes, and this is a national test question, sometimes your P wave will be buried in the T wave. So if you do not see that P wave, or you cannot discern or decipher if it's a P or a T, it usually means that the P is buried in the T. And what does buried mean? Means it's underneath it. Okay. So we have P waves, yes. Next question about my P waves. Are they married? Are they upright? Are they matching? They're all married, and they're all upright, but are they matching? No. So my P waves do not match, which means I have multiple foci. I'm not coming from one place. So again, my questions are, do I have QRSs? Yes. What's my regularity? It is irregular. What's my heart rate? 100 beats per minute. It's more than 100, right? What is, do I have P waves? Yes. Are they matching? No. So I'm coming from multiple foci. And then, of course, you got to do your QR intervals and your QRS intervals and your PR intervals. But we know by our P waves not matching, by our heart rate being high and our rhythm being irregular, that this falls for the rules as a multiple focal atrial tachycardia. All right, so the next ones that you're going to couple together. So we just coupled together your MAT and your WAP. So now let's couple together your PAC, your non-conducted PAC, and we're also going to add in your PAT, your P's, okay? So a PAC is your premature atrial complex. These are premature beats that are fired out by an irritable atrial tissue before the next sinus beat is due. It may or may not be followed by a QRS, and if the PAC is very premature, I mean it came out really early, it will not be conducted to the ventricle. So what is my PAC? It stands for premature atrial complexes, and these are premature beats that fire too soon from an irritable foci, atrial tissue, before that next beat was due. Your rate for a premature beat for a PAC can occur at any rate. Your regularity is going to be interrupted. It's going to be regular but interrupted. Your P waves are going to be shaped differently from your sinus P waves. And your PR is going to fall within its rules as well as your QRS. But your QRS might be absent after a non-conducted PAC. So let's discuss non-conduction real quick. We're talking about your conduction system. If it's non-conducted, that means the impulse did not go through. It was blocked. So how is these PACs resemble or close to your sinus? Remember in sinus chapter 7 you had a sinus block and a sinus arrest. Well, a sinus block is like your non-conducted PAC, meaning the premature beat did not go through. And then your sinus arrest is your premature beat that made it through and gave us that crazy looking QRS complex. So what can cause us to have a PAC or a non-conducted PAC? Medications can cause it, and stimulants such as caffeine, bronchodilators, tobacco, hypoxia, or heart disease. What are the effects? Patients usually do not have any ill effects from an occasional PAC, but if we have a lot of PACs, they can eventually lead to an arrhythmia. Remember, arrhythmia means abnormal and can be a sign of early CHF. What kind of treatment would we give a patient who might be having a PAC? Usually there's none needed. If we do need to send them because they're having too many PACs, digitalis, calcium channel blockers, beta blockers, oxygen, or stimulants. So this is what my PAC looks like. I'm not going to go through all the questions. You should get the idea by now that you should be memorizing the criteria by your questions, by memorizing your questions. And we know the first thing we need to ask, do we have QRSs? Yes. What's your regularity? Just by looking at this, I can tell you it is irregular because this is a very big space in between. It goes shorter, super short, a little further out, and then short again. So I know it's an irregular rhythm. My next question is, do I have P waves? Yes, I do have P waves, but are they matching? No. If you notice, this P wave does not match this P wave, but all of these P waves match. And when you figure out your regularity, you'll find that it is regular here and regular here, but here we have an interruption, and that is the P wave that is not matching. And if you remember, if we from chapter 6, and that's chapter 5. If you remember, if we have an interrupted rhythm, we are to ignore that beat. Okay, and so we have QRSs. We are irregular. My heart rate, and for this one, 10, 20, 30, 40, 50. It is 60. But remember, for a PAC, it can happen at any rate. My PR interval, we can figure that out. We would just quickly calculate. It's from the beginning of the P to the beginning of the QRS and multiply that times 0.04 seconds. And then your QRS is from the beginning of that QRS to the end of that QRS. So a premature P wave that is not followed by a QRS complex is a non-conducted pack, meaning it didn't get through. This is like your sinus block. Non-conducted packs are the most common cause of otherwise unexplained pauses. The rule of T waves, much of the time, the premature P wave is hidden inside the T wave of the preceding beat, which I've already told you that. If the QRS complexes look alike, the T waves that follow them should also look alike. But if a T wave suddenly changes shape, but the QRSs do not, that odd-shaped T wave is probably hiding a P wave. The P wave is buried in your T wave. This is your non-conducted pack. So you'll find that it is regular here and regular here, but we have this pause right here, which actually kind of resembles a sinus block. But you need to look at your P waves and then also the rate. So if you'll notice, look at this P wave here is hidden and your T there. Look at your T and your P's. Look how close. And then this one is a little bit further away. So our P waves, they are upright and they are married, but they are not necessarily matching, which makes us believe that this is a non-conducted pack, but very similar to a sinus block. So you'll see when it comes to interpreting these rhythms, you really need to know these rules, because you can get this one wrong on your national certification if you automatically assume it's a sinus block without checking it out to make sure it is not a non-conducted pack. So the last part of this that I want you to kind of combine together and couple together with your packs is your PET. Again, the key word here is if there's a T at the end of it, it's usually going to be tachycardia, which is fast, right? And if there is an A, it's usually going to stand for atrial. So my paroxysmal atrial tachycardia, also known as PAT, is a sudden burst of 3 or more packs in a row. Remember, what does PAC stand for? Premature atrial complexes. So this usurps the underlying rhythm and then becomes its own rhythm for a period of time. The PAT resembles the sinus tachycardia. So be careful. So your PAC is going to resemble your sinus arrest. Your non-conducted pack is going to resemble your sinus block, and your PAT is going to resemble a sinus tachycardia. So these can be confused very easily, but if you keep them separated in your head and you know the difference between a sinus rhythm and an atrial rhythm, then you'll be able to understand the material a little bit better. So what is the rate of a PAT? Look at this. Your heart rate can get up to 160 to 250 beats per minute because we're counting the pack that it has been interrupted by. Regularity, your atrial tachycardia is regular, but it is interrupted by a slower rhythm. Your P wave are going to be different from your sinus P's. Your PR is going to fall within rules. QRS is going to fall in rules. And look at your cause. It's the same cause as your PAC. And if you remember, your PAC is caused by medication, stimulants, caffeine, tobacco, hypoxia, or heart disease. What are the effects of the heart? If you don't know any of the answers on your national certification and this is one of your multiple choice, that's your answer. Adverse effects on the heart are going to be decreased cardiac output. The treatment is going to be digitalis, calcium blockers, beta blockers, sedation, amiodarone, adenosine, oxygen, or elective cardioversion if the patient is unstable. In order to diagnose a PAC, the PAC that initiates the PAC must be seen. The PAT is simply a run of 3 or more packs, and a T wave that changes shape when the QRSs don't is usually hiding a P wave inside of it. So you'll notice we have your rhythm here, and we have it's interrupted by a whole bunch of premature beats, packs. Okay, and these are conducted because we can see the QRS. If we did not see the QRS, then it would be a non-conducted pack, meaning it did not get through. The next two that you're going to couple together is going to be a flutter and a fib. A atrial flutter is going to be a rhythm that results when one irritable atrial focus fires out regular impulses at a rate so rapid that a fluttery pattern is produced instead of P waves. The AV node selectively blocks out some of the impulses, letting only some of them through. So that's really good to know, note to self, that an atrial flutter is going to have a fluttery pattern, and the AV is going to be selective, meaning it only allows some impulses to come through and not all. This is done to prevent the dangerous fast heart rate. So my atrial flutter, this is where you're going to notice we have two different rates, your atrial rate and your ventricle rate. So a lot of students, the further we get on to EKG, they are still stuck on not understanding the difference between your atrial rate and your ventricle rate. Remember in chapter 1 that your top chambers are going to be your atrium, and the bottom two chambers are going to be your ventricles. And how is that represented on an EKG rhythm? Your P wave is your atrium, your QRS is your ventricles. So how do you get the atrial rate and the ventricular rate? The same way you get your heart rate. If I want the atrial rate, I am going to count my P waves and multiply them by 10. And if I want my ventricular rate, I am going to count my QRSs, which is my 6-second method for heart rate, and get my ventricular rate. Make sure you know the difference between these two. So my atrial rate in an A flutter is going to be 250, but my ventricular rate is going to vary. So in A flutter, I might have all of these P's, and then I'll have a QRS, and then I'll have some more P's, then I'll have a QRS, and these P's are my atrial rate, and then these two QRS's are my ventricular rate. For my atrial flutter, I can be regular or irregular. My P waves are none, and I'm going to see a flutter instead. My PR is not applicable, right? Because I have so many P's. How are you going to be able to tell what your interval is for the P waves? You can't. So it's going to be NA, not applicable. And your QRS, we can still determine our interval, and it will remain less than 0.12 seconds. So what can cause me to have a flutter? Almost always implied by heart disease. Your pulmonary there can be a pulmonary embolus, valvular heart disease, lung disease, or thyroid toxicosis. Look up thyroid toxicosis. This is very interesting. Not so much disease, but a health concern. Thyroid toxicosis is when your thyroid is extremely larger than normal, that the body thinks that there's enough TSH, which is thyroid hormone, in your blood system, and that it does not release the TSH hormone because it believes that there's enough in it from your thyroid being so big. That's what thyroid toxicosis means. So your TSH hormone is not being released, and your thyroid actually winds up being low, toxic low. So thyroid toxicosis. So it's very interesting to look that up. All right, what are some adverse effects on the heart? Again, you should know this by now. Decreased cardiac output. How do we treat a flutter? We're going to give them digitalis, calcium channel blockers, beta blockers, adenosine, carotid sinus massage, and electrical cardioversion. Electrocardioversion, also known as shock. Or if you remember, if you've ever done CPR, your AED. So this is what a flutter looks like. So it's just like what I drew. You'll notice, look at all these P waves, and then we have a QRS, P. So how do you get that interval? You don't. It's not applicable. And how do you get the P wave? Your atrial rate and your ventricular rate, your atrial rate is counting these P's by 10, and your ventricle rate is counting the QRS's by 10. And then we obviously can tell we're going to follow our 5 questions, our rules. AFib. So this is, you also should be coupling this with a flutter. AFib is hundreds of atrial impulses from different locations that fire at the same time. So our heart is simultaneous pump, right? While your atrial chambers are contracting, my ventricles are relaxing. But in afibrillation, that's not the case because everybody's pretty much contracting at the same time, which causes this vibration. The heart, since everybody's contracting at the same time, the heart's just kind of wiggling. The atria depolarize, not as a unit as they usually do, but rather in small sections. This causes your atria to wriggle instead of contract. The atrial fibrillation, the rate can get as high, for your atrial can get as high as up to 700, and your ventricular rate is going to vary. Your regularity is going to be irregularly irregular. Their P waves are going to be none. If there are P waves, the rhythm is not an atrial fibrillation. The wavy baseline between the QRSs are instead. PR, you cannot tell in your QRS. We'll still be able to get that interval, and it should be less than 0.12 seconds. What can cause AFib? MI, which is myocardial infarction, a heart attack, lung disease, valvular heart disease, hyperthyroidism. And what are the adverse effects? What is it? Decreased cardiac output. But also what's dangerous with my AFib is that we can have blood clots. Because the heart is not fully contracting, the blood is sitting in that chamber and it's going to start to clot. The longer blood sits, the more likely it's going to clot. So we don't want our blood to sit in our heart or in our body because then it's going to clot, and if that clot makes it up to our brain, it can cause a stroke, and it also can cause a pulmonary embolus. How do we treat AFib? The blood flow is stagnant and clots can develop. Restoring atrial kick by converting back to a sinus rhythm can dislodge these clots, sending them into circulation, and it can cause a stroke, MI, or pulmonary embolus. If the duration is less than 48 hours, the goal is to convert the rhythm back to what? What are we comparing all of our rhythms to? Sinus. Digitalis, calcium channel blockers, beta blockers, amiodarone, and cardioversions are ways to treat an AFib if it's less than 48 hours. But if an afibrillation is going on longer than 48 hours, we have a risk of blood clots. The initial treatment is aimed to control the heart rate because we don't want them going into an MI. And for non-emergent, we're going to give them anticoagulation, which we're given usually through an IV, and it's going to thin the blood to try and loosen up those blood clots and prevent them from happening. And then we're going to cardiovert, which is your shock. In emergencies, heparin is given, transophageal echocardium is done to rule out your atrial clots, and then cardioversion will occur. So this is just a good little image to show you if that clot gets up to the brain, it can cause a stroke. So here is number 1, the blood clot can form during AFib. Notice your heart is vibrating. We're not completely contracting. The blood is then going to clot, and then that clot right here is being pushed through the bloodstream, but when it gets to these little outlets, that clot is too big and it causes a stroke. And this is what AFib looks like. So you notice the lines are wiggly. A flutter, your P waves were wavy or sawtooth-like. So the last one that you're going to learn about is your supraventricular tachycardia. There's a little trick about this. I always think of SVT as my super hyper friend. If you remember the periods when an impulse will be taken, a second impulse can come through or not, the absolute refractory and the super hyper friend, right? So your super hyper friend is the one who takes the candy from the stranger. They don't listen to nobody and they're just hyper all the time. So your supraventricular tachycardia is known as your SVT, SVT. T. Again, that T is going to stand for tachycardia. But the trick with this one is we don't really know if it's coming from my ventricles or my atrium. So the catch-all term is given to the tachycardias that are supraventricular. They originate in either the sinus node, the atrium, or your AV junction. So you can't really go by that V ventricular and assume it's coming from the ventricles. And even though this is in the chapter of your atrium, you cannot assume that an SVT is coming from your atrium, because your SVT is going to come from either a sinus, an atrium, or an AV junction. Can we know the exact origin? No. P waves are not discernible in an SVT. My rate is usually going to be 130 or higher. I'm usually greater than 150. It's going to be regular, but P waves, can we tell them? No. If we can't see our P waves, can we get the PR? No. QRS, we can still see them. We can get that interval. And what causes me to have a super fast heart? Stimulants, hypoxia, or heart disease. What are the adverse effects? If you don't know it by now, you should. Decreased cardiac output. How do we treat SVT? We're going to give them adenosine, digitalis, ibutylide, calcium channel blockers, beta blockers, oxygen, or we're going to electrocardiovert if unstable. This is your discussion question. Make sure you read up on it so that you can answer it accurately. This is what an SVT looks like. It's very symmetrical, right? Very pretty. But can you tell if that's a P or a T? No. So can we tell our P waves? No. We have QRSs, but look how fast we are going. So we are going at least greater than 150 here. So then that leads us to our practice. All right, so we have made it to your practice section. The rest of the slides are your practice. I just want to say a few things, and I'm going to do maybe 2 of these with you just so you can see how to do it on your own. But I just want you to note that for this rhythm in particular, strip 1, it's obviously going to be an SVT, right? Because we just looked at the SVT. But I don't want you to fall for the trap of memorizing what rhythms could potentially look like without following the rules of those, or the criteria of those rhythms. So this one's pretty easy to predict what the interpretation is, and you're going to find that the more and more you do these, the more easy it is to figure out what type of rhythm it is. But just always remember the first thing you need to do is to follow your rules and ask yourself these questions so you can determine. The whole goal of rhythm interpretation is to find out where that rhythm is coming from, and what type of treatment we need to do for these patients who have these rhythms. So if they're in an SVT, we need to get that heart rate back down, and we need to treat the patient. But keep in mind that these rhythms, these are just examples of what your rhythms can look like, and in real life, they're not going to be as perfect as they are on your PowerPoints. And you'll see, just research and look up examples of EKG rhythms, and you'll see that they're not perfect like they're showing us on these PowerPoints. So my first question on this rhythm is, do I have QRSs? Yes. And if you don't remember, my QRSs, they're the first thing we need to look at, and they are the spikes. Whether you're looking at the bottom or you're looking at the top of them, my QRSs, we can determine them by the spike. And then the waves, we determine the one before the spike should be P, and the one after should be T. But in this case, we do not see a P coming after that T like we should. So we do not have any discernible P waves. And if we do not see a P wave, we can assume that that P wave is hidden in my T wave. Okay? So my first question is, do I have QRSs? Yes, I do. My next question is, what is my regularity? So, how do I determine that regularity again? I'm going to count the boxes in between. I know that one big box is going to be 5 little boxes in between, right? So if I count, or I could even add 5 plus 5, how many boxes are in between this one? 10, 10, 10, 10, 10, 10, 10, 10. So the further I go down, I'm noticing I have what looks like to be a regular rhythm. Its regularity is regular. Okay. Now, what's my heart rate? If I have a regular rhythm, remember, to determine the heart rate, we have 3 different methods to choose from. We have your 6-second method, your memory method, and your little block method. The mean, to get the average, is going to be my memory method. So I'm going to use my 6-second method, not memory. I'm going to use the 6-second method, and I'm going to multiply my QRSs by 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40. So my heart rate, my mean average for this regular rhythm so far is 140 beats per minute. Okay? Now, my next question is, do I have P waves? Well, we already know we can't tell if we have P waves, right? We know that we have them. They could be hidden in my T wave. So we're going to put NA. So if I cannot determine my P wave, can I determine my PR interval? No, I cannot. So my PR interval is also going to be not applicable, NA. My QRS, can I figure that out, that interval? Yes, so I'm just going to erase this first section so that we can figure out what my QRS interval is going to be. Remember, the QRS interval, we're going to measure from the beginning of the QRS to the end of the QRS. So I want to see, where does the beginning, and I'm looking for the change from the segment to the QRS. And when does it go back to a segment? So here it looks like 2 boxes in between. 1, 2. 2 times 0.04 seconds is 0.8. So we're going to put 0.08 seconds. So now we're going to look at my answers and try and pinpoint them in the rules. If I have QRSs, I'm regular. My heart rate is 140. We know that a normal heart rate is 60 to 100. I can't tell my P waves and get my PR interval, but I have a QRS and it's within limits. I am more likely what type of rhythm? In this case, it is an SVT, a supraventricular tachycardia. Now, remember, for supraventricular tachycardia, it can either come from the sinus node, your atria, or your AV node. And what's that treatment? What's the cause? What's the adverse effects of an SVT? So that's, make sure you put on your note cards and you're reviewing your note cards. Okay, sorry about that. So I'm going to do one more rhythm with you. Now, if you're looking at this and you're trying to predict what this is, it's kind of hard to tell. So that's where you've got to do your rules. Don't rely on memorization. Don't memorize with the examples what these rhythms potentially can look like, because this is just to give us an idea, and nobody's heart rate is going to look exactly the same. Everybody has a different heart. Everybody's heart rate is going to look different. So we cannot rely on the image in our memory to tell us what kind of rhythm it is. We have to answer these questions. So by looking at this, I can already tell that this is either going to be an irregular rhythm or it's going to be interrupted. It could be a pack, because I'm noticing by just glancing at it that these 2 consecutive QRSs are closer than the ones in front of it, than these 2, okay, and so forth. But again, I'm guessing. Can we rely on our memory No. Well, we can rely on our memory, but we cannot rely on it we don't want to guess. We don't want to go with our gut on this. We want to have an accurate answer. We want to give the doctor the exact type of rhythm that patient is having and not a guess. Because you notice the treatment for these different rhythms, there's different treatments for them, and we don't want to put that patient into that situation. We want to be as accurate as we possibly can. So my first question is, do I have QRSs? Yes. Now it's my regularity. So I'm going, again, each one of these boxes has 5 little boxes, so I'm going to count by 5. 5, 10, 15, 20, 25, and I see one little box there, so I'm going to say 26. Again, 5, 10, oh, you can add them, 15, 20, I see 3 here, 23, and I see 4 here, just 27. Again, 5, 10, 15, 20, 23, 24, 25. Now here's that short one I noticed. 5, 10, 15, 16, 17. 5, 10, 15, 20, 21, 22, 23, 24, 25, 26. So you'll notice 25, 27, 26, they're within 2 boxes different from each other. But 17, I'm having a big jump, right? So I am regular, but I am interrupted by what? A premature beat. That beat came too soon. My next question is, do I have, what's my heart rate? So now I'm going to count by 10. 10, the QRS is 20, 30, 40, 50, 60. My heart rate is 60 beats per minute, which is actually kind of normal, right? My P waves, do I have them? Yes. Here's one. That looks like the first one. That looks like the first one. This one looks a little bit different. It's more rounded. It's not as pointy. But do I have P waves? Yes. Do I have one for every QRS? Yes. What is my PR interval? So I'm going to erase this first section so we can get it. My PR interval, we're going to measure from the beginning of the P wave to the beginning of the QRS. So here's the very beginning of that P wave. And that QRS begins right on that dark line, which makes it easier for us. So how many boxes are in between? 1, 2, 3. What is 3 times 4? 12. My interval is 0.12 seconds long. My QRS, now remember, wherever I measure that PR interval, I have to stay on that same beat to get my QRS. And it looks like the QRS ends in the middle of this box right here. So I'm just going to go ahead and round it off and say 2 boxes. And 2 times 4 is 8. So now we need to interpret it. Remember, this is seconds. So I have QRSs. I'm regular but interrupted. My heart rate is 60. My PR interval is within limits. And my QRS is within limits. Everything is normal except for I am interrupted. So this would be a PAC, premature atrial, and I believe it is complex. And it's going to be conducted because we see a QRS. Oh gosh, what am I doing? Sorry, y'all. My mind's on something else. PAC, P-A-C. Let's see. Okay. This one, we can predict this one easily, and I'm just going to point out real quick that if you look at your P waves, we can't tell, are they P's or are they T's? They're fluttering. They look like a sawtooth. If you ever see saw, I don't know, that cuts the tree. It kind of looks like this, right? Pretend that's a saw. This is a sawtooth look. This is obviously a flutter, but still do your rules. Go through the steps. The more you do it, the easier it becomes. This one is obvious as well. Look, it's vibrating. So we know that this is most probably, I don't know why I'm putting V. I hope I didn't put V on the last one. A fib. If I put a V on the last one, I meant to put an A. A fib. And then this one, it kind of looks like it could be an SVT. It kind of looks like it could be sawtooth. So you're going to have to go through the questions to do this one. Same thing. This kind of looks like it's could be interrupted, a pack. It could be a WAP. No, it could be a mat, or it could be a fib. So you have to go through your questions. And then this one, this could be a non-conducted pack. Okay, so just go through you practice, make sure you practice, and reach out to me if you have any questions. I am more than happy to help you. Email me 100 times if you need to. I'm here to help you. I want you to learn the material. I don't want you to give up. I've been having multiple Zoom meetings a week with students in this class, and it is not a problem, and the student feels so much relieved after meeting with me. Just shoot me an email, and we'll have a Zoom conference, and don't hesitate to reach out to me. And good luck!